in pieces. It'll be up on YouTube in pieces. This is the formulation of the problem. You're usually given a network like this with no arrows on it. So it's a bit different looking than the min cost flow problem because it doesn't have arrows on it, but you're supposed to put the arrows on there. That's what took me time to figure out because there was no arrows on there. And so when there's no arrows on there, you could go backwards or forwards. So it was unclear to me, like, could you go from Seattle to Portland to Boise and go back to Seattle? Technically you could, but then I looked into it a little bit more and it says that you're only gonna go in one direction. So from this case, you're gonna go from west to east, Seattle to Denver. So you have to put the arrows on there. And the way they drew it kind of funny so that it looked like Salt Lake City was almost underneath Butte. And so I was like trying to figure out, well, could you go which direction you're going? So you have to figure that out. And it turns out that Salt Lake City is, I already know that, is west of Butte. So putting that down, this is a path, this is a path, this is a path. You have to do this part. This was not in the book. I know, sorry. These are my arrows. If you look at my solution, which I'm just going to give to you as an online version so you can have it, but you'll see that I erased quite a bit as I was learning. I was learning how to do this kind of problem. So I'm not a fan of actually coming in with perfect notes and showing you a perfect example, because then you'll think that I'm always perfect. That's not the case. As I learn, I'm like, oh, that's what they meant. I'm a normal human being, at least I think so. My sisters disagree. They said I've been hanging around math departments way too long. Real math departments. This one's not a real one. This math department has seen the gym from the inside. Most math departments I've been in have not seen the gym from the inside. Most possibly even the outside. So, question is formulate and solve to find quickest route.
What is it from Boise to Salt Lake? What's the error for that one?
Boise, so it doesn't, Boise to Salt Lake, 6.
What's the error?
This way.
So
So they kind of lined it up. They were a little bit messy in it, but they kind of lined it up so you can see which direction everything goes. So that's the question.
So, how are we coming up with like where the arrows are going? Like what?
So,
Because
they say something about you can go from Seattle to Portland, Seattle to Boise, and Seattle to Butte in the text. So that they say something about that, but the rest of it they didn't.
so you just put those in there.
So just to be full disclosure, I asked on ChatGPT, could something technically go from Boise to Salt Lake, and then Salt Lake to Butte, or can they go from Butte to Salt Lake? Is that possible? Because that was not given to me in the problem, and the cases you can't. They're all from here on out. After the first 3, they're going from west to east. So you actually have to look at a map and go, where is that? It's actually west of this, right? So you have to put the arrows up. And even the first 3 arrows weren't given. It was in the text that you could possibly go from Seattle to Portland. Okay, so the first step is decision variables. They look really different. There are no quantities. They're not bringing any product or units of anything across. And so these decision variables, the way they describe it in the book is they say that it's a binary decision variable. This is called, it takes on different names. It's called indicator function, indicator variable. Sometimes it's called categorical variable. They have this in mechanical engineering or electrical engineering. They call it switched variables. It's also known as switch. There's a whole bunch of names these are called. know you guys are gonna laugh. We'll see how mature you are. It's called the bang bang function. So these are some of the names these things are called, but basically it is, to me it's a function. So example is x sp would be 1 if it's a made up number. Just we assigned it into categories. You either decide to move down that path or don't decide to move down that path. If you decide to move down that path, we're going to assign it the number 1. If you do not decide to move down that path, you're going to define the variable to be 0.
Would it be from Seattle to Portland, not Boise? If you said SP, not SP?
Oh. I think I changed my mind halfway. Portland. And let me give you my legend, and I'm going to give you your first board problem. S was Seattle, because I didn't want to keep writing these up on the board, like on the thing. Portland. And Butte. BI was Boise. YBI, because I didn't want to use BO because that has other meanings, and I didn't want to use BS.
That's funny.
SLC was Salt Lake City. And then GJ was Grand Junction. BL was Billings. That's where we used to get our school clothes from, because they had a Walmart. In Charlotte, or Cheyenne, sorry. And then D was Denver. So what I'd like you to do is to make, keeping track of all of this is hard. So I want you to make a table from to decision variable. So I started you off. I said Seattle to Portland, that's XSP. So you have to find all of them. I'm just gonna give you, what do they call it? A developmental opportunity to find all of them for this one example. You know that it stinks when someone says it's a developmental opportunity.
How many should it be?
You find out. I'll try not to erase this. If you see me erase this, start to erase this, say something. Bene?
I'm confused about the example that you put for the indicator variable. I was one if she's trying to say, is that just like a filler?
So here they go. They're gonna make a decision. They could take 3 different paths, right? They could take this one, or this one, right? Whichever path they take, when I take that path is going to be 1. And these other ones will shut off because I've already decided to take that path. So in the link between, I could go this way, or this way. So I'm gonna have a decision variable for each one of these. Once I have set my path in motion, that value will be 1, and the other ones will be shut down as 0.
Okay, so
Right.
if you go,
If I'd gone this way, it would be SBI, X sub SBI would be 1 in that case. So these variables have only 2 values. They either can take on 1 or 0. 1 means that path was chosen, 0 means it wasn't.
oh, okay.
And they can't go either way in the path, it's whichever
Yes,
is
cannot go either way in the path. This type of problem is unique in the fact that you have to go from left to right,
Okay.
Unless it says.
unless it says
Like
otherwise.
Seattle and Portland is east or west.
Yeah, they
Okay.
have to say it, yes. Alright, so make this table. And I did it. I actually listed them out. Do what I did. Pretend it's a soup that's running your PT. You do whatever he does. You do whatever I do. This is Dr. T's mental PT today. Go up to the boards.
This one was brown too.
You'd rather do the burpees? Is that what you said?